Okay. So this is Eyoas. Thank you for the introduction. I will start presenting about the Kansat 30, which was held in at Nihon University, Tokyo, from August 19 to 29. So a little bit about myself. My name is Eyoas Ergetu. I'm a researcher at the Kyushu Institute of Technology. Recently, I finished my PhD at the Kyushu Institute of Technology. And then my specialization is satellite structure subsystem, and then also analyzing satellite system complexity. So this CLTP is basically, I think it was described very well in the previous presentations. It's a 2-week intensive course on the HeptaSat training for experiencing hand-on satellite assembly and integration, as well as satellite system engineering. So my presentation will be my experience and then the opportunity that's being offered with this training program. So as you can see, CLTP is a training using a kit called HepSat Sat kit, which is a 1U CubeSat basically. So with this CLTP program, we try to have the idea of a satellite development from the beginning, from the concept phase, all up to the operation, launch and operation, using this the kit that you see in the right side. And then with this training, we have covered a lot of topics, basically the whole process of CubeSat development or satellite development. So at the beginning, we start with the components, satellite components, and those components become a subsystem, and then all the way to the system, and then how we integrate all together. And then with this subsystem, CubeSat subsystem, during the training, we did a testing, troubleshooting, practical activities, and we also do assembly and integration of the subsystem to make it independent or one unit satellite. So at the final, we also try to learn how we can operate a satellite when it's in the space. And also at the last week of the training, we also learn how to teach or transfer the knowledge to the other people. So we learn the effective teaching methods with practical teaching activities. So there was a lot of international experts coming together to learn this CLTP program. So showing the program overview, I think it has been already described. So the training was designed from the lecture to hand-on experience. At the beginning, during the first week, we had a short lecture at the beginning, learning about all the satellite subsystem, and then after the short lectures, we will have a practical session where we do the programming stuff, the assembly stuff, and testing stuff. So it was both lecture, but mainly with the practical activities in the satellites. So the first week we had several lectures at the beginning with a lot of coding and programming. And then we learn about all the satellite subsystem, the development process, all the principles. And then the final day of the first week, we had the chance to, to have a group and then develop our own mission idea, and then work on those mission over the weekend to come up with, a satellite mission that can be, launched to the space, simulating the real environment. And then with the next weeks, what we did is actually we presented the result that we have progressed through the weekend with the missions that we selected, and then we presented our ideas, and then got all the feedbacks and comments from the senseis, from the experts, and also from all the participants. So after that, as I said, we had a teaching practical also class. So how can we deliver the knowledge that we have received when we go to our respective countries? So that was also very informative. And then the last day was actually implementing that teaching techniques on the actual training scenarios, where we have a company, people coming to the training facility and receive what we have received for 1 or 2 weeks. So in terms of training resources, it has been already explained that we have modules that we were using for 2 weeks. And also there was another additional module that we use it to train other people during the last day of the training. And then we also have a 1U Heptasat kit that I showed previously, which contains all the basic satellite subsystems, and including payload and sensors that we use to experiment with the programming. So during the handoff training, as I said before, it's not only about lecture. So the unique part, I mean, the unique characteristics of this training is that it's not a class only based lecture. So we had the chance to actually work on the actual subsystem, you know, assembling, also writing the codes so that all the subsystem communicate each other. So this was very helpful for us because most of the time the satellite system engineering is given in the class, but with a practical experience, we have learned a lot of things. We made a lot of mistakes. With that mistake, we also improve our skill in different aspects. So some of the skill that I have personally got is programming skill. I'm from the more of from the mechanical side. So with this training, I managed to develop my programming skill, electronics, assembly, you know. So this was very helpful for me. And also during the testing and troubleshooting phase, we also learned a lot of additional experience. So I continue with the practical teaching training that I mentioned before. So at the first week of the last day of the first week, we develop our own mission concept, where we implement that concept with the actual available resources. So we have been given some budgets to buy some additional sensors so that we can show or demonstrate our mission concepts. So with that, with our group, my group was together with Professor Mohammed Lufti, and then assistant from the Japanese side also. So we try to manage to develop a concept that is demonstrated in the actual 1U satellite. So as you can see here, this is our mission was to combat a desert locust propagation forecasting missions. So we have this issue in Africa and in the part of Asia, where we have the locust tree moving in a mass and destroying a lot of agricultural fields. So this was the idea that we selected, so that how we can predict their propagation, the speed, and then the distribution and so on. So we implemented some sensor, for example, a camera sensor, and also in addition to the camera, we also had infrared sensor, where we can also try to take the thermal distribution of the agricultural field, so that we can identify the location of the locust, and then how they travel and the speed and so on. So using this sensor that we bought from the actual market in Tokyo, so we integrated all the sensor with the subsystems, writing the programs. So we demonstrated the concept of our mission. Actually, the actual mission that we proposed was the constellation mission, which is actually more than one unit CubeSat. But due to the resource that we have, we try to demonstrate the idea with one CubeSat. So in this team collaboration work, we had a lot of success because of, you know, we have a lot of diversity. Professor Mohammed was from a mechanical background with image processing and computer science. So he tried to bring his knowledge from that side. Me also, I have the designing integration experience. from the Japanese side also, they are helping with the coding and so on. So we try to bring all the knowledge and experience together, and then we manage to demonstrate our mission effectively. So the key lesson learned in this CLTP13 is that we had the chance to learn or develop our technical skill in writing programs, hardware integration, bringing all the subsystems together and testing all those subsystems. And also some soft skill, we try to be on time during daily training sessions. So that also we learn how to manage time, and we also learn leadership and resource management. Also, we have allocated some budgets to buy our sensors. So we have to use those budgets properly. So that also teach us how the resource should be managed in actual satellite project. And communication between each of the participants in our group also was something that we have learned during the training. And in the practical knowledge, as I said, there are a lot of challenge in the small satellites. The small satellite, as you know, the space is very constrained. So we need to know how to manage the space. So that's also one of the challenge that we have faced during the training, and then we learned that also during the training. So in the future, personally, my future aspiration is to transfer this knowledge to other students or engineers, and to teach about small satellite technologies and help them to build, satellites in locally. So I'm from Ethiopia. I didn't introduce myself actually. So I'm from Ethiopia. So in Ethiopia, space has not been developed that much. So there are a lot of human resource challenges. So with this knowledge that I acquired, I try to transfer that knowledge to young engineers, students from the universities, so they can try to build small satellite in their own university or schools. And also, as I said, capacity building, I will try to have similar kind of training methods that I received and then implement in Ethiopia, so that a lot of people have the advantage of learning about CubeSat as well. And also collaborative opportunities. So with the community that we have developed during the CLTP13, a lot of people coming from different background, from different countries. So we had these networks that will grow, to build something tangible in terms of research, activities, and collaboration projects. So lastly, we had a lot of social gathering, cultural experience exchange opportunities. We had a lot of chance to go to Japanese local cuisines and taste very delicious Japanese foods. I was very happy to have that opportunity. And also we have a cultural exchange between different countries coming from different parts of the world. So, and then also we have networking opportunity that we have acquired from those experts coming from different places. So thank you very much. I really appreciate the UNISEC-Global for giving me this opportunity to learn about Heptasat, CubeSat, and space technology more. So I would finish my presentation here. If you have any questions, I will receive questions. Thank you very much.
Okay, fantastic. Eyoas, thank you very much for the presentation.